And the word on the street is we need to scoot the camera off to the side a little bit because there's somebody with a big head that's right in front of the camera. It's not, okay, I'll put people with small, of course you're here now, I just marked you absent, but I'm glad you're here. All right, yesterday, 5 new derivative rules came your way. I want to get some hands, what are they? You don't need to know all 5, but there are 5 new derivative rules. Henry, then you're frozen.
Quotient. Quotient rule.
No, that wasn't new yesterday.
Oh.
Floor. No, there were 5 new derivative rules yesterday. Evel, get me started.
The extended product.
No, that also was not new yesterday. Oh my God, it's like yesterday didn't happen in your brains. No.
It's the one that I don't know.
Oh my goodness. Paul, save me.
The sum rule.
Nope. Nope. Gerson is not going to let me down.
I can't promise that.
Yes, I can promise. Go. Can you give me one of them?
No.
Oh my goodness. It wouldn't take much to go to your notes from yesterday and find them. Adrian.
The derivative of sinus.
Oh, thank God.
Oh, wow.
Derivative of
Yeah, I know that.
sine of x. What's the, shut up, y'all. Okay, derivative of sine of x is what?
Cosine of x.
Cosine of x. Oh, now look at all the hands. No, actually, all the hands is 1. Okay, derivative of sine of x is cosine of x. Yes. Michelle, help me out. Redeem your class here.
The derivative of e to the x.
Derivative of e to the x is e to the power of x. Good. Jesus. Jose, sorry.
The derivative of cos of x.
Derivative of cosine of x is
Negative sine of x.
negative sine of x. Okay, that's 3. There are 2 more from yesterday. Jackie.
The derivative of e to the power of negative x.
Derivative of e to the power of negative x is?
E to the power of x. Negative e to the power of x.
It's negative e to the negative x power. And Karina, Landon.
Derivative of negative sine x equals...
Oh, no, not that one. There was one more. The one that I modeled beautifully that we did on the calculator. I'm going to call a kid in Ohio if I need to. Gerson, don't let me down twice.
The natural log of x.
Oh, thank God. Derivative of natural log of x is?
1 over x.
1 over x. These 5 you have to get locked down. You just have to get them locked down. All right, so now let's go ugly, shall we? So now that you've got those 5, I want to start combining these things together. I want to push your thinking. Just realizing you've got new hair and it looks great. It looks great. New hair in the back. All right, so number 1, f of x equals 2e to the x plus x e to the negative x plus x squared of x plus e cubed. This is how we roll in calculus class. I want to go find a derivative. Take a couple seconds, have a conversation with somebody near you. How are you going to find that derivative? No, focus. Focus. Alrighty, friends. I want to find the derivative of 2e to the x. What is the derivative of 2e to the x?
2x.
Not 2x. Nope. It's just 2e to the x. Because what's the derivative of e to the x? E to the x. You're multiplying by a constant, so this is 2e to the x. However, the next one, x e to the negative x. I'm saying x e to the negative x, but there's something I'm not saying. Gonzalo, what's the thing I'm not saying? What's the right way to say this as a mathematician? X e to the negative x is the same as saying I'm setting you up poorly.
Negative.
X e to the negative x. What's happening there? What's the operation here?
Negative.
X e to the negative x. They're right next to each other. You've known this since about 4th grade. Andy, what does it mean when there are two things next to each other like that? We're multiplying. So if I'm multiplying x e to the negative x, how am I going to take a derivative? How am I going to take a derivative if I'm multiplying? Product rule. Hold on. Product rule. Because this is x times e to the negative x. Product rule says take the derivative of the first part, 1, leave the second one alone, plus, now it's the first guy, times derivative of the second part. And the derivative of the second part is negative e to the negative x. Check. Plus x square root of x. Also the same as saying x times the square root of x. Guess what? Product rule. Get it for me. Another product rule. X times square root of x. Take the derivative of the first, leave the second one alone, plus the first times the derivative of the second one. Derivative of square root of x, you need to know is 1 over 2 square roots of x. There are other ways you could have found that derivative, but we're pretty good. Plus e cubed. I have to take the derivative of e cubed. No, I don't have to take the derivative. Yes, you actually do have to take the derivative. Yeah, otherwise, we're having open rebellion here. But what is the derivative of e cubed? It's not 3e squared. It's 0. The derivative of e cubed is 0 because it's a constant. Duh. Okay, e cubed is a constant. So if you wanted to write plus 0, that's fine. Andy?
You know how you said that the 2 was a constant? How come we kept that?
Because that's a constant that you're multiplying by.
Oh.
Not a like
Adding.
constant that I'm adding or subtracting. Okay, Evil.
If you're responsive, we don't put plus 0 if that minus 1.
Oh, no. I'm just writing the plus 0 to make it super obvious that there was a constant there that we took the derivative of. Alright, see what you guys can do at the next one. H of x equals sine of x times e to the x. Find h prime of x and h double prime. I must have low expectations here. I even put the multiplication dot in there this time.
So we know if it's multiplying, we take the derivative of the first, which is cos x, then times e to the x plus sine, plus
H of x equals sine of x times e to the x. If I'm going to product rule this, I need to know the derivative of sine of x, and everybody knows derivative of sine of x. Cosine of x times, leave the second guy alone, plus, now we leave the first guy alone, sine of x, times derivative of e to the x. And derivative of e to the x? E to the x. Honestly, how many guys have that as your derivative? Looking good. So not done. So not done with this problem. We're not moving on. Why not? Go find that second derivative for me. Oh, I'm going to be such a proud papa in a moment. Taking the derivative of cosine of x times e to the x. Yes, ma'am. Derivative of cosine of x is negative sine of x.
multiplying.
But when we sketched the graphs yesterday, that's not what happened. Oh, I just heard it. It was like angels singing to me. I heard someone say, I know I need a product rule over here because I'm multiplying, but how am I going to find the derivative over here? Another product rule. It's possible to use multiple derivative rules. I love it! Derivative of cosine of x, negative sine of x. Leave the second one alone. Plus the first one times the derivative of the second. Product rule here, derivative of sine of x is cosine of x. Leave the second part alone. Plus, leave the first part alone times the derivative of the second part. How many guys honestly had that as your derivative? Got a couple of folks. How many guys were like on your way? Good. And I'll tell you, if this is the free response, I am loving it. All the points. But I want to have conversation about multiple choice. I will hide this from you on the multiple choice. Jackie sees something, Gonzalo sees something. How am I going to hide this? Rebecca?
The negative sign of x times e to the x, and then the sign of x.
The negative sign of x e to the x and the positive sign of x e to the x? How am I going to hide that from you?
Wouldn't you cancel?
They cancel. Love it. Not done. I'm still going to hide this because I'm mean, Daisy.
And you might make the e for the cosine put 2 cos.
Cosine of x times e to the x plus another cosine of x e to the x. Jackie, what's that actually equal to, Jackie?
If we had cosine of x times bx to the power of x, like parentheses squared.
Not squared, not squared. It would be squared if I was multiplying these together.
It would be 2.
I have cosine of x e to the x plus another one. That means I have 2 of them. Yeah.
Well, not the response. If we were to do that, I'm still going to put it right.
Oh my god, if you stopped right here.
No. Well, we would. That's not right there. That's
Okay, if you went all the way here on free response, absolutely you'd get all the points. But on the free response, I'd hope you would stop here. Everybody okay?
Yeah.
Ready for a challenge?
No.
Oh, come on. Henry! Henri! Can you read number 3 for me? Using your best mathematical notation.
Where g of x equals the natural log of x times sine of x.
Wait, whoa. I asked for the good stuff. Read that again.
The natural log times, there's no x.
There's no x there.
Oh, of
So natural log, one more time, son.
natural log of
Sine of x. Of sine of x. Natural, say it with me, natural log of sine of x. Of sine of x. Henri, keep going.
minus sine of
Wait, one more time.
sine of
Sine of e to the x.
plus e to the sine of x.
No, e to the power of sine of
Power
x.
of
Okay, why am I making a fool out of Henry other than it's fun? Why am I trying to emphasize this word of? Not product rule. Chain rule. There is a mama and a baby. You have a baby. Every time you say sine of, that means mama and baby. Inside function and outside function. So I want to get this one. Here we go. G prime. The chain rule says take the derivative of the mama. What's derivative of natural log?
1 over x.
Careful. 1 over x. But natural log of sine of x is 1 over sine of x. Because it's chain rule. You take the derivative of the natural log, but you leave her baby alone. Don't stop. Chain rule times cosine of x. Because that's the derivative of sine of x. Minus derivative sine of e to the x. The mama is the sine. Derivative of sine? Cosine of e to the x times derivative on the inside, e to the x, plus derivative of e to the power of sine of x. Derivative of e to the power of x? E to the power of the stuff, right? So e to the sine of x times cosine of x. Oh, I'm sneaky. Oh, and tomorrow when I turn 45, I'll be even sneakier. Yes, I think I've said it 14 times this week.
You look like you're 30.
Yeah, thanks. Your grade did not change. Paul.
For 1 over sine of x.
Oh, speak it. Speak it.
I was just gonna ask. Would it be okay if you put 1 over x times sine?
Oh, no, not that. I thought you were going to go deep. I thought you were going to go deep here. 1 over sine of x times cosine. I was having those high expectations for a moment, and then he dashed them.
I got it now though.
Okay, is the same as cosine of x over sine of x true? I'm hoping for deeper. Cosine of x over sine of x. Someone in here's got it. Not him. Cosine of x over sine of x. There's something. Mr. Link is in Massachusetts, Dallas, wherever he is, and he's excited because Sylvia knows
Cotangent.
cosine of x over sine of x is cotangent of x. So if you really want to impress me, g prime of x is cotan of x, oh my god, minus the cosine of e to the x times e to the x plus e to the sine of x times the cosine of x. That is good. Real good.
Will we get extra points?
No.
Sure. You might get the question right.
It's not worth it.
Okay, but seriously, free response, don't simplify, don't ever simplify in free response. Multiple choice, I will hide it from you. Alright, I want to see what you guys can do with this next one. I'm so excited.
Will you use our calculator?
No, you won't need your calculator. God, I'm so excited.
Excuse me?
Oh, some
Wait,
people
what? How
are
do you know?
furiously flipping through their notes thinking maybe we sketched this one. Maybe we talked about it once. No.
Right around this time.
Yeah, but then isn't tangent affect the derivative of cotangent?
Jackie.
Oh yeah, I see that.
Yeah.
But then it isn't
Cos squared.
Yeah, that was really cool on your
Yeah.
So basically, cotangent is the opposite of tangent.
So it's just basically the quotient.
And then can you pick up the thing?
Times the derivative
mine is sine.
Oh, I am tricky, but I am not fooling Daisy. Jose, am I fooling you?
Negative sine.
Yeah.
Good, I also do. And then over close up.
I think it's.
Are you saying that the derivative is secant squared of x?
I we're supposed to rewrite it.
I know. That's
Did you just prove that?
Over.
Or did you look that up on your phone when I wasn't looking?
No, I use my sources.
You used your sources. It is true that the derivative of tangent of x is secant squared of x. I'm curious if, what would you do? We've not talked about the derivative of tangent of x. What could you do? What legal things could you do? Andy? Tangent of x is the same as sine of x over cosine of x. That's not the derivative, Floor. We're just saying, hey, based on trigonometry, tangent of x equals sine of x over cosine of x. Floor, this one's all yours. How are you going to find the derivative for me, Floor?
You do Lodi high.
Lodi high.
Oh, I don't know if it's a minus or plus.
It's a minus.
Minus high deal over low low.
So what did you just do? What's it called? Quotient rule. Is everybody okay that when you rewrite tangent of x as sine over cosine? Sheila, you're good. This is quotient rule. Good. Let's do it. Low. What's low? Cosine of x. D high.
cos x.
Cosine of x minus
Sine of x.
sine of x. D low.
Negative sine of
Negative
x.
sine of x all over
Cos
cos of x squared. That's good. That's not good enough. There's more. Gonzalo, what do you think?
Wouldn't you be able to cross out cosine of x squared from the top and bottom?
So people keep falling for this. I see the cosine of x here. I see the cosine of x here. The problem is I've got these terms over here. It would be like saying that 4 plus 5 divided by 4, just cancel out the 4's. And if you don't do that. We don't do that. Order of operations says you make this 9 over 4. You can't just cancel because of the addition. What you can do though, there is some stuff here, Marilyn.
You can separate them by the subtraction of the middle, in the middle.
Oh, like make it 2 different fractions? That works. Here's something else you can do, and maybe you're not going to see this coming. Cosine of x times cosine of x, you know what that is?
I mean,
Cos squared.
It's cos squared. Well done, Andy. Cos squared means cosine times cosine.
Yeah.
Minus sine of x times negative sine of x.
Negative.
Wait, one more time.
Sine x squared.
Minus sine of x times
Plus
negative sine of x
sine
becomes plus sine squared of x, and in the denominator, cosine squared of x, and we're still not canceling. What do you got for me?
I have a question.
Yep.
So how do we know, like, if, like, the subtraction sign is gonna be a subtract, or it's just a negative?
It's both. It's both. You're saying minus sine times negative sine, so you could say minus negative sine squared. Minus a negative is positive. Or you could say negative sine of x times negative sine of x and just tell me it's positive. Now here's the thing, this is good. There's the rare calculus student who knows what else we can do. Karina, what else can you do?
Isn't there like cos squared plus sine squared equals tangent?
Oh,
It equals 1, right?
cosine squared of x plus sine squared of x, if you go back in your trigonometry memory bank here, is equal to 1. It's called the Pythagorean identity. Pythagorean identity. That was so sloppy. So we've got 1 over cosine squared of x. And that's really good. But Jose knows that the derivative of tangent of x is secant squared. I'm still not sure how he knows that. 1 over cosine squared, Sylvia, what do you got?
It's because 1 over cos is secant. So
1 over cosine of x is secant of x, so what's 1 over cosine squared?
Secant.
Secant squared of x. So I want to add on to our list here, the derivative of tangent of x is secant squared of x. Nice. All right, last one. See what you guys can do at number 5. You can do this. Yep.
So here, I know this is the long and kind of derivative minus.
I work on that
So it's low d high minus high low times the derivative of the denominator.
Couldn't it be f of x times cos x?
except for like inputs.
Because here, this is the derivative.
So then we will use the product rule.
The quotient on low d high. Denominator times derivative of the denominator times the derivative of Alright, find the equation of the tangent line. By this point, it needs to be on autopilot. I need the point, I need the slope. Where do we get the point from?
They give it to you.
They did? They gave you the x. The point is going to be of the form pi over 4 comma something. Where do I get the y value from?
Just plug it in.
You plug in. So you have to find f of pi over 4. Oh gosh. Cosine squared of pi over 4. Yes, this is fair game and you need to know your trig. cosine squared of pi over 4 is the same as cosine pi over 4 the whole thing squared. Yeah.
Isn't cos of pi over 4 square root of 2 over 2?
Okay, cosine of pi over 4 is the square root of 2 over 2, and now you have to square that. So that means square root of 2 over 2 times square root of 2 over 2. What is that? Square root of 4. 2 over 4. It's going to be a half. So my point is pi over 4 comma a half. And I hope everybody's okay with that. Now for the tricky part, the slope, you need f prime of pi over 4. F prime. Well, to find f prime, I need to find the derivative of cosine squared of x. That's the same as cosine of x squared. Chain rule. That's going to be 2 times cosine of x to the first power times negative sine of x. You start with cosine of x squared, bring the power down, leave the baby alone, reduce the power by 1, multiply by the derivative of the inside. So that's f prime of x. F prime of pi over 4 is 2 times the cosine of pi over 4 times negative sine of pi over 4. Pi over 4 we already know. We do, what was cosine of pi over 4? Square root of 2 over 2 times the negative of the sine of pi over 4. Oh, I'm not telling. Especially since it's over there on the board.
Square root of 2 over 2.
Square root of 2 over 2. So 2 times square root of 2 over 2 times negative square root of 2 over 2. Over here, this part is going to give you negative square root of 4, so 2 over 4. So that's 2 times negative a half is negative 1. We've now got your slope. Your slope is negative 1. You've got the point. You've got the slope. Karina, what's up?
Couldn't you use product rule too?
You could have used the product rule if you wanted to. Okay, equation of your tangent line, L of x is going to be negative 1, and then plug in the point x minus pi over 4 plus a half. That's great. Really good. So not done. Right? We've got the equation of the tangent line. Now I need to approximate f of 2. What's f of 2 approximately going to be? Whatever you get when you plug in 2. It's approximately negative 1 times 2 minus pi over 4 plus a half. Done. Okay, here's what I want to do. This is a rare treat. I want to give you guys some time to start on the homework. Okay, so forget about the sticker challenge. We'll deal with that some other time. Tonight's assignment is assignment number 40, round 2. Round 2 mixes all these derivative rules together. You've got 5 great examples in your notes. So assignment number 40, round 2 only. I did not give you nearly enough room. You're going to want to do the work on a separate sheet of paper. I am absolutely going to pick this one up tomorrow. It is absolutely going to get graded. I want this to go well. Oh, and the best looking person in the group is in control of the cups.
So this would be like chain, right? Of x of baby.
You mean the chain one? Yes, ma'am.
So this one, look at this. Every color just either the x what's the curve? So it'll be either the x squared, right?
So,
And then you would do the baby. I don't think there's another chain. The baby's just x squared. F prime would be e, becomes ex, right? F prime is ex, oh, so ex,
Right? So it's chain rule. So would it be e to the x?
what, the x squared alone? It was like x squared? X squared alone? But what do you leave?
Are you trying to judge her?
The x squared?
So then you have to forget about the bomb. So you should
Where were you born?
for this one, it would be e to the x of 2. But it's like power over power.
Oh my
It wasn't
god.
as simple.
So you probably
Right, you're gonna multiply by the derivative of that exponent.
So it's so it's e to the x, right?
Oh, not that one. Where's the seeds now? Take the derivative of mama.
That's right.
Like this, x squared to negative.
Let's do Sunday.
Because that X is
Sunday.
So we don't have the
Final
value.
draft 2 days after the original deadline.
How you know when it's up?
It's called the PowerPoint. It's out there.
first one. I got e to the
oh
power.
my God, yes.
No, it's 2 weeks above it.
No, I'm telling you, this is the only one.
It looks like it's
Okay, right, so now I'll find the derivative of that.
I think it's due on Friday.
Oh, where am I falling?
And then
Who are you
the day after the final.
No, this is what I.
Okay, it's e to the
Power of x dot.
take derivative of mama.
Can I come? I thought this was the baby. Oh. I thought this was the baby.
How do you do it?
Isn't that the baby?
I see
This is
it.
the one that's I think the x squared is the baby.
Yeah, but
That's all I had right.
Wait, they have a green cup, they have a green cup.
Oh,
Yeah.
sorry. I just raised
Okay,
it.
I'm coming. They have a red
I
cup.
have it right.
Oh.
I have it right. It's x squared.
E to the power of x squared. And the times 2x.
What is that? You said that's x squared?
And so what's the here is
E to the power of.
Okay, hold on.
Yeah, e to the power of x.
How's it, then what's the derivative of e? How's it, like,
Alrighty, friends. Let's talk about number 6. Oh. Okay. Gonzalo, hater of calculus right now. Can you read that one?
F of x equals e to the power of x
Oh wait, e to what?
to the power. Oh.
Oh! But as goofy as that is, what I need you to train your brain is every single time you say the word of, what rule do you need? Chain rule. So if it's chain rule, where's the baby? The x squared is the baby. And so the mama is e to the stuff. How do I find the derivative of e to the stuff?
That one is just ex squared.
It's e to the x squared because the derivative of e to the x is e to the x. The exponent never changes. And then what? Now take the derivative of your baby. And the derivative of the baby?
2x.
2x. I'm curious, how many guys honestly had that on your own? Okay, nice job, Diego. Alright, let's go,
That's it.
let's go ugly.
That's it.
Yeah. Yep. Alright, try number 9. We'll talk in a bit.
can we plug in numbers?
I never understand if it's a constant. Like if it's a constant, then why would you like do work?
I'm saying a is a constant.
So we know
So
it's
a of x of e
one
of e.
the
8 times x times e.
Oh, so this time we multiplication. Oh, okay.
Great. How do you find the derivative?
That's it.
No, because it take a number times x times e times let's say like it's basically
Oh, I thought
it's one.
Yeah, that works.
So we have we have the chain rule and the
Same thing we did last time. It was like
and the product.
phase by itself.
So ¿cuál es So we
Alrighty, friends, I've seen this on a couple of papers. Things are good. Stay with me. If I'm going to read this in the way it should be read, A, not A of X, AX, or like A times X, and then what?
times e
Times e to the bx power, which means you know what rule you need. You need the product rule. I see you, Jeanette. Give me a second. Okay, so now here, yes, product rule, but I'm looking at the AX as like the first guy, and the e to the bx as the second guy, or the second factor. So let's find the derivative. F prime of x, what does that product rule tell me to do?
Keep the first derivative.
Take the derivative of AX. A is a constant, right? A is a constant. And Paul asked earlier, like, can I just like plug in a number? Can I think of like that as like 4? Sure, what's the derivative of 4x? 4. So what's the derivative of AX? A. That's the derivative of the first guy times the second one. Plus, now it's the first guy times derivative of the second one. Careful. E to the power of bx. There is a baby here. That exponent with the exponential, there's always a baby. The exponent's always the baby. So the derivative of e to the bx, e to the bx times b. And that's good, that's a great answer. Yeah, Karina?
How come you didn't start it with the chain rule instead of?
Because if I'm reading this, I'd say it's ax times e to the bx power, and I hit that multiplication operation before I hit the exponent operation. Paul, and then Sylvia.
So you see
I
on
mean,
number,
Sheila.
you see on number 7, it's like ln of.
ln of, yep, there's a chain rule.
So how do you know like if it has a dot, you're multiplying. It's not just when it's next to each other.
Correct. Okay, I'm number 9. Is there anything you could do, or I could do, to hide this answer from you on the multiple choice? I care about this. What do you see, Michelle?
The E with the B to the X power.
The e to the bx power? What about it?
You can combine them together.
Combine them? I can't really combine them together. These guys are not like terms.
Yeah.
There is something else I could do here. There's something else I could do. Jalissa, do you see it?
Right, 2.
No, you can't write it 2 because these guys are not the same. There's an F word I was hoping to hear from somebody.
Factor.
Factor. Marilyn, is that what you were going to say? What could you factor? There's the A in both and the E to the BX power. So factor out AE to the BX, and what are you left with? 1 plus what's left here. You took out the A, you took out E to the BX, what you're left with is
X times B.
X times B or B times X, same things.
What?
Where did you get X times B?
I factored out the A and the E to the BX, the A and the E to the BX.
Oh.
Okay, real quick, I want to avoid an embarrassing moment tonight when you guys get home and you do 14 and 15. Someone is going to think I have lost my mind.
Yeah.
They're going to think I wrote the same problem twice. I didn't. I didn't.
Sine of theta.
Sine of. Derivative rule over here. Chain rule number 15. Product. Sine of theta. Right? The difference is sine always has an angle. There it is. Product rule. Excellent. Now that we've handled all the easy ones, you guys are good to go and finish the hard ones.